Today, let's look at how to use the mean variance optimization approach to help clients allocate assets during the portfolio construction process. To discuss anything about modern economic portfolio construction, one important person to mention is Professor Harry Markowitz. His theory on portfolio efficiency tells us that to get a higher portfolio return, we need to bear additional risk. If we know the return of the assets, their standard deviation, and their pairwise correlation, then we can adjust the asset allocation within the portfolio so that the return is maximized at a given level of risk. If we trace the returns of these portfolios that have different risk levels, we get a concave line that is called the efficient frontier. On this efficient frontier, the Sharpe ratio is being maximized while taking into consideration of the investment constraints of the investor. To discuss the investment constraints, let's look at the utility function. In this function, the happiness or the utility that a mix of assets brings to the investor is a function of the asset's returns, their standard deviation, and also the investor's own risk aversion, as denoted by the Greek symbol lambda. Investors' risk aversion is evaluated on a scale of 1 to 10. An average investor has a risk aversion of 4. As lambda increases, the utility derived by the investor from the investment decreases. An investor with zero risk aversion has the highest utility level, as represented by the black curve in the graph. Other constraints include unity constraint, where asset weights in the portfolio should add up to 1, and also non-negativity constraint, where no borrowing or shorting of assets is allowed. These constraints are applied because they reflect the realistic investment process, although they may decrease the overall expected return of the portfolio. Now, let's get back to Markowitz's theory regarding mean variance optimization. Suppose now we have run the optimization process by taking into consideration the asset returns, their standard deviations, pairwise correlation, and investors' own investment constraints. We get a graph as below that shows how to optimize the asset allocation so as to get the best returns at different levels of standard deviation. For example, if we start at the zero risk level where standard deviation is 0, we see that all investments should be made in cash. If we put a vertical line at any other given level of standard deviation, we see that it gives us a certain kind of asset mix. This asset mix is the strategic asset allocation that maximizes the return to the investor given the investment constraints. We also observe that, as the standard deviation increases to the right, the percentage of cash in the asset mix decreases, while the percentages of other investments, such as bond and equity, increase. This is because bond and equity offer higher returns at a higher level of risk. I hope you have enjoyed this video. If you have any questions, please let me know. Happy studies!